My clock says 2:55. Are we really 10 seconds out? Or is that the buffering?
We were 10 seconds till it went live on the stream. So I guess 5 minutes out till we begin the actual event.
Got it.
So just wanted to make a quick announcement. Thank you to everybody joining us on the YouTube live stream. We'll be beginning here in about 4 minutes or so. So just hold tight and we'll begin the event. Thank you so much. Hello, this is Nancy Mendonça, and I would like to welcome you to the AAM Aircraft Ecosystem Working Group. To set the stage, this is one of 4 ecosystem working groups
For more information and recordings and materials from the other three groups, which are cross-cutting, airspace, and community integration, please visit the NARI webpage on slide 5. Carl Russell will be leading this group. Carl works under the Revolutionary Vertical Lift Technology Project, RVLT, which is NASA's main project for focusing on vertical lift at the vehicle level. He's worked in several technology areas in RVLT since 2011, but most recently on experimental investigations of multi-rotor vehicle performance. He is currently the Associate Project Manager for Partnerships, focusing on where the project can engage with industry, academia, and other government programs and projects to further vertical lift technology. Prior to his time in vertical lift, Carl spent 3 years working in airspace research, mostly looking at weather impacts on en route aviation. He has a BS from Boston University and an MS from Stanford in Aero and Astronautics, and is a member of the Vertical Flight Society, and recently served as the technical chair on the Electric VTOL Symposium held in San Jose earlier this year. Carl, thank you, and over to you.
All right, thanks a lot, Nancy. I appreciate the introduction. So, like Nancy said, my name is Carl Russell, and I'll be leading the aircraft working group, which is one of the 4 working groups that we have here. Just to go to our schedule for the day. Let's see if there we go. So here's our schedule. This was posted on the website, but we also, just for your information here, we'll do some introductions here. It's probably not going to take more than 20 minutes. It'll probably actually be less than that, just to kind of get everybody oriented. And then I'll introduce the panel. We've got a really great group of 6 folks from the industry here, and we'll be hearing a lot of what they have to say about kind of some of the various aspects of aircraft technology, challenges, where we go from here, and that sort of thing. We are using the online Q&A through Conference.io, so hopefully you've seen a link to that on the NARI website. So the link is here. You can copy it down here. I'll leave it up for just a second, just in case you don't already have it. What you'll find there is that you can upvote questions that you find most interesting, and we'll be going to those later on in the panel, just to keep this conversation going and make it as interactive as we possibly can. Obviously, since we're doing this all remotely, we're using the tools to the best of our ability. Okay. One other thing here is just to kind of announce a couple of upcoming events. First off, hopefully you have the link that actually says kind of what these different events are. But if not, they're here at the top of the page. For this particular group, again, since this is the aircraft working group, certainly expect that the people who are attending this are chiefly interested in actual aircraft technology. So on June 25th, there will be a UAM concept of operations overview meeting, and then the next day there will be a focus group on the ConOps on Pillar 1 and 2, which hopefully you're familiar with the pillars, but if not, I'm going to go over them just briefly on the next page. There will also be a cross-cutting working group logistics meeting, an airspace working group kickoff meeting, similar to this one. Those ones have not been announced yet, but stay tuned. So that's what's coming up in June, and then in July, there will be additional community ConOps focus group meetings on pillars 3 and 4, which are the airspace pillars, and then pillar 5, which is the community pillar, on July 10th. So those are the upcoming events that we have. Jumping right into where we are, as I mentioned, there, in this space, NASA has found it useful to kind of organize the UAM technology, or AAM technology. As Nancy mentioned during the community meeting last week, we are still working on how to coalesce around around terminology. But for the moment, UAM is still on this chart here as urban air mobility. So the kind of technology areas are organized into these 5 pillars: vehicle development and production, individual vehicle management and operations, airspace fleet operations management, community integration, and airspace system design and implementation. Now, as the aircraft working group, we are chiefly interested in pillars 1 and 2. So again, these are the things that are important at the vehicle level. There are these different technology or different topic areas within pillars 1 and 2 related to the vehicle. And again, these are kind of a convenient way to organize the kind of technology areas and organize the discussion. Okay, and then kind of going a little bit deeper into this, just to kind of show kind of how we define these different areas. I'm not going to go through and read these, but obviously there are a lot of there are a lot of pieces here. We're going to cover several of these today, but certainly we aren't going to get to any one of them in depth. Any one of these could easily take its own week-long workshop to fully hash out. But the idea behind today's kickoff is really just to kind of introduce everybody to what are the topic areas that we're interested in, and get everybody kind of thinking along these lines. And kind of setting the stage for the future meetings that we're going to have. One of the things that kind of differs between the aircraft working group and the community working group. So for those of you who may have tuned in last week, Nancy mentioned that the kind of community area is one where NASA doesn't necessarily have a very high level of investment. We are invested in that area, but a lot of that is coming from community groups such as CAMI and things like that. On the vehicle side, NASA is very heavily invested in vehicle technology. Much of that is through the RVLT project, which I represent, and certainly through the other projects such as AAM, T-Cubed, and others. And so, we have our ideas of what are the important barriers and how to approach these things. But what we're looking to do here is really just have a discussion and engage the community and understand, what are the things that are important to the community in terms of vehicle technology, where are the pain points, what are the things that it may be possible to actually collaborate on. And ultimately push the technology forward to actually enable urban air mobility. So I've left this one up for a little while, and hopefully you've kind of gone through and read that. And this is the second pillar, which relates more to the individual vehicle management and operations. Again, these are areas where we've kind of looking at the broad spectrum of what is necessary to enable urban air mobility. These are the things that we find at the vehicle level are important. So that kind of sets the stage for what are the general topic areas. Now, I want to talk a little bit about how this working group is moving forward. Now, again, if you had dialed in last week, you would have heard Nancy talk about FACA and what that does in terms of limiting our abilities to have a strict organization to this group. So really what we're kind of doing here is acting, or as NASA is, we're acting as a facilitator for the discussion, but we're not really looking to direct it. We really want to allow this to be kind of free form where we can, and allow the various stakeholders in this community to have input. And we're working on what are the best ways to do that, and still remain within the kind of bounds of what we're able to do in this kind of construct. So previously, there had been talk of having organized subgroups. At the moment, we don't believe that is going to be possible, and still remain within kind of the bounds of FACA. So it will be one single open group. The meetings will be kind of similar to this, where you may not have to actually register. You just have to follow a link and go to a website, and have the discussion, and we'll work on what are kind of good ways to actually allow for interaction. It becomes a little bit tougher, when we look at what's available with the kind of conferencing tools out there, and which ones we as the government are allowed to use, because that actually is another kind of limitation that we have. But we'll do the best we can until we're kind of back to being able to meet in person. Eventually, the idea here is to be able to have these open discussions in person, and that certainly allows for a lot more actual kind of engaged discussion. So we're planning on having meetings up to once a month. We don't have a real specific idea of how that's going to go, but again, we're still kind of working on it. Like I said, this kickoff is going to cover a broad range of topics. I don't expect that we're going to get through all 9 or so items that fall under pillars 1 and 2. There's just no way that we would be able to do justice to any of them. This will really just kind of give a flavor of what we're going to be talking about in the aircraft working group here. So we'll be having these subsequent meetings, and each one will be focused on a single topic. Likely we'll probably organize them around those kind of 9 areas. But we're certainly open to suggestions of how we want to do that. And again, I want these discussions to be these discussions to be more engaging with the audience. It's great if we can sit here and kind of have half a dozen of us just kind of talk at the audience, but if we can actually find ways to engage the audience and the community, and have everybody give input, I think that's what really makes this type of working group valuable. So as for the leads, I'm the working group lead here for aircraft. So if you have ideas of things that the working group may want to focus on, or for example, maybe a topic to cover, you can certainly email me. We also have our project coordinator, Brianne Stallsmith, and she will be the one who is kind of making everything run smoothly. Not to put too much pressure on you, Brianne. Okay, I think that is the last slide that I have in terms of introducing the discussion and the working group itself. So I'm going to switch over to introducing our panel. So what I'm going to do here is I'll give a brief bio for all of our panelists, and I'll just run through them, and then I'm going to have each of our panelists give some brief opening remarks, and then we'll go to some structured discussion here. So let me just pull these bios up here. And you guys get organized in alphabetical order of company. So David, you're lucky that aerospace starts with an A. So David Silver is the Vice President for Civil Aviation at the Aerospace Industries Association. He joined AIA with over 20 years of experience in aviation, most recently serving as a Director of Engineering and Regulatory Affairs for the Boeing Company in Washington, D.C., where he worked extensively with both regulatory and legislative committee leadership. He also has an array of experience in working and collaborating with a variety of international organizations involved in certification and validation programs. David also served as the 787-8 Deputy Fleet Chief for the introduction of aircraft into commercial operations. He worked with airline customers, regulators, and airplane program chief engineers on model-specific technical and safety issues affecting the in-service fleet to increase reliability and ensure smooth operation for the airlines. David also has vast experience working airplane systems for airplane programs such as the 777 and 767. He served for 22 years in the Army National Guard as an engineer officer with successive leadership roles culminating in battalion command and assistant G3 for Washington State. He received the Legion of Merit and retired as lieutenant colonel in 2014. David holds a BS in engineering and a BA in political science from Arizona State University and MS in engineering management from Washington State. He's also a graduate of the U.S. Army Command and General Staff College and a fellow of the Royal Aeronautical Society. This is the part where I would normally ask for an applause, but we can't hear those right now. Okay. Next up is John Damish. John Damish is a senior director of new business ventures for Boeing Next, a business division building the ecosystem that will define the future of urban, regional, and global mobility. He's responsible for collaboration with third parties to advance Boeing's future mobility initiatives, including oversight of the SkyGrid joint venture that is developing a software platform for the safe integration of unmanned and autonomous vehicles into the global airspace. John was formerly the chief growth officer for InSitu, a Boeing subsidiary whose unmanned products have more than 1.3 million operational flight hours. During his tenure at InSitu, he established the commercial business unit and oversaw the strategy and marketing functions of the company. John came to InSitu through Boeing's acquisition of 2D3 Sensing, where he was president and CEO. He holds a Bachelor of Science degree in Mechanical and Aerospace Engineering and a Master's degree in Business Administration from the University of California at Irvine. He's also a licensed commercial pilot and a certified flight instructor. Welcome, John. Next up, Jim Ryan. Jim joined Bell in May of 2019 and is their Senior Advanced Vertical Lift Program Manager in Washington, D.C. His responsibilities cover unmanned aircraft systems, aircraft autonomy, and artificial intelligence. A retired U.S. Army Master Aviator, he is qualified in multiple military fixed and rotary wing aircraft. He also holds commercial ratings in multi-engine fixed and rotary wing aircraft. Since 2002, he has been a leader in the advancement of DoD unmanned aircraft and has extensive experience integrating them into the National Airspace System. Prior to Bell, he spent the last 11 years in the Pentagon covering DoD unmanned aircraft policy, training, qualification, acquisition, and combat operations. Welcome, Jim. Moving on to Greg Bowles. Greg is the head of government affairs at Joby Aviation. He joined Joby in 2019 with over 20 years of experience in the aviation industry, most recently serving as the vice president of global innovation and policy for Gamma. Greg is also chairman for the ASTM F44, an international committee which addresses issues related to design and construction, systems and performance, quality acceptance test, and safety monitoring for general aviation aircraft, also known as CS Part 23. They're less than 19,000 pounds and with fewer than 19 passengers. Welcome, Greg. Next is Hervé Martins Rivas. Hervé is the Vehicle Partners Engineering Lead at Uber Elevate. He works on eVTOL conceptual design and collaborates with suppliers and vehicle partners towards designing and certifying quiet, high-performance eVTOL aircraft. Before Elevate, he was controls and aerodynamics lead for the Cora self-flying eVTOL aircraft at Kitty Hawk. He was part of the original team at Kitty Hawk starting in 2010 and worked on several piloted and autonomous full-scale eVTOL aircraft as the company evolved its concept. And welcome, Hervé. Happy to have you here. And last but not least, Tom Gunnarsson. Tom is the regulatory affairs lead for Wisk, a joint venture between the Boeing Company and Kitty Hawk Corporation to develop a self-flying all-electric air taxi service. He is currently leading efforts to foster progressive regulatory approaches for eVTOL aircraft and the emerging urban air mobility marketplace. Before coming to Wisk, Tom was the FAA Advanced Technology Branch, interfacing with industry and other civil aviation authorities on the development of consensus-based safety standards for small aircraft. While there, he coordinated an FAA regulatory feasibility study on electric propulsion. Prior to the FAA, Tom served as president of the Light Aircraft Manufacturers Association and was chair of the FAA Aviation Rulemaking Advisory Committee that developed the light sport and sport pilot rules. Tom is a pilot, flight instructor, and has operated several flight schools. So welcome, Tom, and welcome to everybody on the Aircraft Working Group Kickoff panel. I'm really happy to have you all here. I think this will be a great discussion. So why don't we move into just some brief introductions. I'm going to leave up the slide here just so you can still see everybody's photos. But let's just have some introductory remarks from everybody on the panel, and we'll go in the same order that I did the the bio. So David, if you could take us away here.
Great. Thanks, Carl. I want to start off by thanking NASA for hosting today's workshop and inviting me to be on the panel. These workshops, I think, highlight the strong partnership that exists between industry and NASA. And through these conversations, I know we're going to help shape the future of advanced air mobility. So a little bit about us. As some of you know, AIA is a trade association in Washington, D.C. We represent more than 300 companies across the aerospace and defense industry, including manufacturers, operators, and suppliers. And we are fully committed to supporting NASA's work to ensure that they have all the components in place to support the eventual emergence of advanced air mobility. And as AIA has been working, we've strengthened our government partnerships with other organizations and with other governmental partners such as the White House Office of Science and Technology Policy, the DoD, the DOT, and sub to the DOT, of course, the FAA. The question I get most often asked is advanced air mobility real? So what I wanted to do as part of my opening remarks was just look at the numbers. So NASA reported back in 2018 alone that there was over $1 billion spent or invested in the UAM. 2019 was another strong year with reported another $1 billion. And we've seen projections that indicate in future years that investment is going to continue to grow. Since 2008, we've invested over $3.2 billion globally in unmanned aircraft systems. The good news for all of us, I think, on the call is that over 2/3 of that money was invested in the U.S. In regards to AAM specifically, the Vertical Flight Society has announced that there are over 270 different eVTOL designs in various stages. And we have from the FAA confirmation that they have over 10 open certification projects. And finally, we got NASA's Advanced Air Mobility National Campaign and the DoD's Agility Prime that will both work in partnership with the FAA to rapidly advance the development of this technology. So the numbers show that AAM is very, very real. And it is coming quicker than I think most people realize. So how do we ensure that the investment bears real fruit? And there are many, many areas that we can focus on, but from an AIA perspective, there are a few specific components that I lose sleep over. Number one, vehicle certification. Number two, community acceptance, which will need us to work with our partners at the state and local levels. Number three, public and private partnerships, now both new, like Agility Prime, and the expansion of eligibility of programs that have existed for years, but we've never used them for issues like AAM. Four, making sure that our supply chain is ready for the influx of work that's going to be coming its way. And then finally, infrastructure. All of these areas are going to require strong government-private partnerships, and that's what AIA is committed to working on now and into the future. And I hope during today's panel, we'll have an opportunity to delve into all of them to some small piece. So with that, I'll go ahead and turn it back on over to Carl.
All right, thank you very much, David. And next we'll go to John Damish for your opening remarks here.
Thank you, Carl, and I'll echo David's sentiments and say thank you to NASA for this invite. I'm honored to be on a panel with such distinguished fellows. In terms of my perspective on the panel, I represent the Boeing Company and specifically a group inside Boeing called Next. To put us on the map for most of the audience, what Next's job is inside Boeing is to explore the future mobility space and how that will apply to the Boeing Company and how we can, kind of reach back from the airline level down into other alternative mobility regimes, especially those below 500 miles where something like 95% of us choose to drive instead of fly. There's certainly plenty of opportunity space there. I agree with just about everything that David had to say in terms of the stats, the numbers, the momentum. For me, and one of the questions that we wrestle with inside our company is, the when. There are a lot of different inputs into that equation, a lot of different motivations depending on the players that are in the space. For the Boeing company, it is not whether it will or won't happen, it being AAM, but when. And we are taking a decidedly long view of this space. We're putting safety first, making sure that the engineering and the approach to certification and ultimately operation of said vehicles is done with safety first. And to that end, we're not racing to be the first ones in the market with an AAM vehicle as an example. So most of my perspectives that I'll share throughout the course of this panel today are going to be decidedly from the business perspective. We're spending a lot of time there to understand, what are the use cases? What are the proper personas? What are the individual value propositions that AAM presents to those personas in those use cases, and make sure that we use those and a clear view of the marketplace to drive future product requirements. Because as we all know, building aircraft is neither cheap nor easy. It's a significant investment, and that investment has to pay off. To use the fun cliche, the juice must be worth the squeeze. And in order to determine that, you have to do the research up front to understand where that opportunity really lies as an aircraft OEM. So again, thank you for allowing me to join this session. I'm really looking forward to the discussion to come.
All right, excellent. Thanks, John. Jim Ryan, over to you.
Thanks, Carl, for the opportunity. Many of you might know us best as Bell Helicopters. We're a 85-year-old tech company. Truth in advertising, we've only been doing VTOL for about 78 years. I highlight that because as a company, we've stood in this very same spot about 74 years ago when we certified the world's first civilian helicopter, the B-47. We built over 5,600 of those, and there's still actually some flying today. That aircraft became a catalyst for the very actions we're discussing today. It helped usher in concepts like heliports, urban air taxis, news helicopters, medical life flight, and even external cargo delivery using sling loads. While we continue to remain a leader and innovator of both military and civilian VTOL aircraft, Bell is also committed to the new transportation network. To do that, we created a separate innovation team with some of our best engineers, led by Jason Hurst, with the focus on leap-ahead eVTOL technology. Our internal element efforts relevant to this conversation are our Bell Nexus passenger carrying aircraft, and separately our cargo eVTOL aircraft called the Autonomous Pod Transport, or APT for short. As a company with a touch of gray hair in the room, we look forward to this new transportation network, and we are excited to lend our knowledge and experience to the challenges ahead. Thank you.
All right, thank you very much, Jim. And next we'll go over to Greg Bowles for your opening remarks.
Hey, Carl, thanks very much. Yep, Greg Bowles here with Joby Aviation. So at Joby, by the way, also, I need to get a new headshot because I think I don't look like that anymore. That's like a 15-year-old headshot. Wow. So at Joby Aviation, we are working on all electric airplanes that are also VTOL capable. Our aircraft is piloted, carries 4 passengers. It can go over 150 nautical miles with a 30-minute reserve. We're planning to put that aircraft into commercial service in 2023 on an FAA-135 on-demand operation. So we'll also be the operator of those aircraft. We are maybe on the leading edge. That was just maybe that we've kind of bound the environment now. We're potentially on the leading edge of some of the activities. I think there are a number of companies out there actively flying right now. We're one of those. And so we're excited to talk through the technology, talk through some of the critical aspects of safety and noise and cost-effective maintenance and cost-effective operation through this group. So thank you.
All right, excellent. Thanks, Greg. And sorry for the old headshot. I think I just for that one I pulled it off of the web. Let's see. Moving on, we'll go over to Hervé Martins-Rivas. Hervé, your opening remarks, please.
Thank you, Carl. First, I want to say, in the last 10 years in the eVTOL field, it's been really amazing to see the progress and maturation in the field, a really massive increase in public interest and investment, a great influx of engineering expertise, and really, at the end of the day, incredible progress towards making this a reality, with multiple aircraft flying today and engaged with FAA through certification. As many of you know, Uber Elevate has been pioneering UAM for a while now. We're working with vehicle and infrastructure partners on making UAM a reality by 2023, with the goal of saving people time and alleviating city traffic in a sustainable, environmentally friendly way, ultimately changing the way billions of people move around cities. We have announced partnerships on the vehicle front with Bell, Aurora, or Boeing, Pipistrel, Embraer, Jaunt, and Overair Karem, most recently Hyundai and Joby. All are really like pioneers of eVTOL, doing very exciting work developing those vehicles. And it's really great to see the interest today on this topic and the excitement of the industry at large. Thanks for having me.
All right, excellent. Thanks, Hervé. And then finally, we'll go over to Tom for your opening remarks, please.
Thanks, Carl, and thanks, NASA, for putting this together. This is a great opportunity to share information amongst us. So as Hervé had pointed out, WISC has a long history of development, for which actually we've been through a number of name changes, the most recent with the joint venture with Boeing, WISC, and we're very proud of that collaboration, and we see a lot of good things coming from that. From the regulatory perspective, this particular new marketplace is really exciting because it has taken advantage of some of the developments that we've seen come in the not too recent past. For instance, the use of industry consensus standards for means of compliance. I started in that realm with light sport aircraft when that rule was being developed, and we've seen where that's gone, and the safety record there is very good for a program that allows a lot of latitude for manufacturers to build quality products for the general public at a good price point. And it's gone on from there, having been successful to allow for Part 23 to be revised to more of a performance-based rule. Again, using industry consensus standards, which really has opened up some possibilities. So I spend a lot of my time on the standards development side. And one of the projects I'm helping lead with Anna Dietrich is doing a gap analysis of means of compliance to aircraft that fit within the marketplace we're talking about today, assuming it has a wing and it flies primarily wing-borne, to cover the gaps in those means of compliance, to make sure that there is a pathway forward for new entrants who want to participate in this and end up with a type certificate so that they can do commercial service. So I'll leave it at that. I know we'll have a lot more discussion. Thanks.
All right, excellent. Thank you very much, Tom. Okay, so next we'll move over into the kind of panel discussion here. Let's see if I can get this next slide to go. I just want to remind everybody that we are using the online Q&A for answering questions. One question came through here on the online Q&A, which got a lot of upvotes, and I'll go ahead and address it right now, which is, what exactly is the aim of this group? That's a good question here, and it's kind of morphing a little bit. As I mentioned, we had to change kind of the goals and structure of the group based on what we are able to do within the bounds of FACA. So at the moment, our goals for this group are essentially to create a forum for community input into the important technical areas for urban air mobility, eVTOL, particularly in the areas of pillars 1 and 2, which are the aircraft technology pillars. So, again, like I said, this. A lot of this was intended to be a lot of in-person interaction, and so we are kind of doing our best to adapt here and keep the conversation going. And so, unfortunately, the virtual environment doesn't allow us quite the amount of interaction that we would otherwise like to have. So we kind of ask people to bear with us as we feel our way through and try and come up with the best way to develop community input and allow people to talk and arrive at consensus and that sort of thing. This also is an opportunity for that we as NASA are taking to kind of better publicize some of our work and engage with the community and let people understand what we are doing, so that we can better reach our goal of advancing technology. We also want to identify potential areas of collaboration, either between the government and industry or between, industry and other industry partners. We are hoping to be a facilitator in that area as well. So hopefully that answer satisfies the question. We'll keep the discussion going. And, one of the things too is, again, this is intended to be a community group. And so if there are kind of goals of the group that people would like to see, then we certainly encourage that kind of input from the group as we figure out exactly how we go moving forward. Okay, so I'm going to end my presentation sharing here, and we will go back to just video. And I'll turn my video on so that I'm not just a voice in the darkness here. Okay, so we'll go on to panel discussion, and I'm going to start with just some individual questions that I prepared for our panelists. But as questions roll in on the conference IO Q&A, I'm going to probably go to those just because I want this to be as interactive as possible given where we're at right now. So we'll start with, I have a question for Hervé. So Hervé, as the Vehicle Partners Engineering Lead at Uber, you've probably seen a lot of good ideas as well as a lot of bad ideas from vehicle manufacturers. In a broad sense, can you talk about what separates the good ideas from the bad?
First things that comes to mind for me about that is that it's really an incredibly exciting time. This open field of design is like an engineer's dream for all the engineers in the group today. It's like being in the early 1900s and imagining what an airplane should be when you don't quite know yet. Kind of a blank canvas for creativity and innovation. Kind of unique in the aerospace, coming before the optimization and design consolidation phase. Really all uncertainties and possibilities. So for the engineers out there, that's super exciting. Then maybe a little bit more directly to your question, there are some of the physics fundamentals, of course. So one of the first things you probably hear a lot in Uber talks in the past from like Mark Moore or Rob McDonald's. Disk loading is one of the big one, how much power you're going to use. So the disk area you have for the aircraft and for those eVTOLs vehicle, if your disk loading is too high, you're going to use very high power, meaning your energy density of your battery is going to have to come down. That's a big factor. Aerodynamic efficiency, L over D typically. Or L over DE will affect your range and speed. One that's maybe a little bit less talked about, VTOL maneuvering effectiveness. So the arrangement of your rotors or your ability to generate yawing moment with vanes or tilting, including the failure modes, will have a big impact on your design, will go to required thrust overhead, and ultimately weight penalty. So that goes to the viability of some of those designs. Structural challenges, kind of fundamental aerospace considerations. A big one for us as we focus on product is the noise considerations. If you look at a concept with, I don't know, Mach 0.9 tip speed and very small blades, that's for our application in city centers, that's not going to work. So blade solidity, tip speeds are important factor. One that people have been struggling with over the past 10 years is aerodynamic interaction challenges. How the different, typically you have multiple rotors and lifting surfaces, how those interact with each other, sometimes in ways that are challenging. And also very important, the user experience part of it. Can you get in and out of the vehicle? How much space do you have for passengers, luggage? At the end of the day, that's a product that we want riders to use. So all those factors really need to come together. And maybe I'll tweak the question a little bit. And what you want to do is look at what your design requirements are, what's your product. And some people are looking at different markets, different applications. So the questions are, what is your vehicle expected to do? What's the mission with the customer? And then really go from there. It's been the focus of Elevate to think about that, understand the new modality of transportation and what the performance requirements are. Make sure we have products that makes an impact on people's lives.
All right, excellent, thank you. Let's see, and one thing, you mentioned noise as being a really big area, and so that is one thing that for this particular panel session today, I didn't focus on it much, just because I know that noise is something that has been talked about a lot, but it is certainly something that I think a lot of people are seeing as one of the major challenges for these type of aircraft, and that certainly is something that is going to be one of the biggest considerations in actually getting both the passengers and the people on the ground to accept these vehicles. And so I think that all of the points that you brought up were very good. Does anybody else on the panel want to chime in on that? If not, I can move on to the next one. Let's give a couple seconds here. Okay, well, we'll move on. Okay, so next question is for David. So David, the AIA is one of several professional and industry organizations that have a stake in the success of eVTOL and or the AAM, Advanced Air Mobility, Urban Air Mobility industry. Others certainly being AIAA, BFS, Helicopter Association, those sorts of things. What do you see are the kind of key areas where these organizations can help advance the technology, help push things forward?
Oh, all right. Thanks, Bob. So AIA and the other trade organizations that are involved in this space each have a critical role, very critical role to play about bringing industry together and shaping the future of the policies and the regulations that are ultimately going to enable the industry itself. I think one of the critical things for us as trade organizations is to make sure that we understand which of us has responsibility for which priority. In other words, if we're all going out for the same pass, we're not helping anybody. We're just helping one person, one organization. So we've got to agree who's responsible for what, and also what we all consider to be important. For AIA specifically, as I mentioned, we represent over 300 members, a large percentage of which are actively involved in the development of the AAM platforms and also the services. And so I see our job is ultimately to gain the industry consensus positions to then bring that we can then bring to Congress, the FAA, DOD, and ultimately the White House that will enable the policy framework that will allow for all of these technologies to go into place. An example of this would be something like an expansion of the eligibility programs that I talked about earlier during my openings. So helping both government and companies be eligible for programs for already existing loans and grants for infrastructure, and then also for technology development like batteries. The other thing is that we, as a trade association, ultimately, and something very important, we don't pick the winners and losers. What we try to do is ensure that the framework is in place, that there's an even playing field out there for everybody, so that at the end of the day, everyone can succeed in that framework, and we'll know if the job is done by the early 2030s.
That's a good point. And I do have one kind of follow-up question. So you mentioned that it's important that the different organizations aren't kind of stepping on one another in this space. How do you think we accomplish that and keep that from happening?
Yeah, well, it's ultimately through constant dialogue. It's also, I'll be very honest, some organizations have got to be willing to let others lead where they don't necessarily want to. I'll use myself as an example. I think when AIA really got into this and started leading in a number of areas, we did look around and we saw Gamma was doing an exceptional job on some of the battery technology and the certification. And, I talked, Greg was there at the time. I was very comfortable stepping back and saying, you lead, we'll follow, we support. So you've got to be willing to, kind of put your pride aside. And that is actually, to be honest, is a form of military officer. That's a form of leadership in itself. And the other thing is standards organizations, making sure that we're appropriately using the standards organizations. Again, there's no replication, and that we use each of them where they are best able to be used.
All right, great, thank you. Let's see. And again, I'll just see if anybody else on the panel wants to chime in on that, and if not, I'll go on to the next one. So I'll just give you a couple of seconds. Okay, so we'll move on to the next one. So a question for John. This is a bit of a Boeing question, but it's really just because it's based on a comment from a Boeing person. So back in February, there were a series of tech talks at NASA that were done in conjunction with the GoFly competition, which Boeing was a sponsor of. And so during those tech talks, Greg Hyslop, who's the chief engineer of Boeing, gave an opinion that I thought was really interesting, which is that people are willing to get on an aircraft because the passengers trust the human pilot to get them from A to B safely. How do you think that you would earn that? How do you think you earn that kind of trust between passengers and automated or pilotless vehicles? A lot of these vehicles that are being proposed will indeed be pilotless or optionally piloted. So I think that would be an important area. So I'd like to get your take on that.
Yeah, sure thing, Carl. I think so. We've done a handful of customer research projects, both inside Boeing as well as with some of our third-party partners. And, I agree with Dr. Hyslop here. Today, people associate that trust with another human on the airplane whose goals are aligned with theirs, which is getting from A to B safely. So I think that's entirely true. In terms of, how do you define trust in an autonomous system going forward? One of my colleagues shared some information with me, around a trust framework and making sure that you calibrate trust in a way that's appropriate for the task that's trying to be accomplished, right? And a great example is, we have there's computer LASIK surgery today done on your eye, right? There's like very few parts of my body I'm more nervous about than my eyes. And yet we let a completely autonomous system use a laser scalpel to cut them. That's something that I actually place more trust in the system to do than I do a human to hold a laser scalpel. So, it really illustrates this concept of calibrated trust. So, if I was to try to transfer that onto air vehicles, as a flight instructor and a commercial pilot, I kind of still am a bit befuddled that we still have the human aviate and navigate. The systems that we have available today, the technologies that are available today, are more than capable of performing those two responsibility areas for the quote unquote pilot. So that then trends into, how does the definition of a pilot change, right? Today, if trust is imbued in the pilot, how do we provide the traveling public with an avenue to direct that trust onto the system because it's calibrated the right way, right? Calibrated to those activities that improve safety. I appreciate so much what Gamma was able to accomplish in the light sport aircraft area. And I think if you start to pull apart the certification parts of the regs and categorize different classes of aviation, you can see the safety record at the highest level, Part 121, is absolutely incredible. And that's largely due to, redundancies, certification rigor, dual crew, CONOPS, and procedures that are designed around minimizing the opportunity for human error to create, a bad effect. However, we don't share that same safety record in the general aviation and the business aviation communities, right? 80% of fatalities in those communities are caused by human error, either controlled flight into terrain or loss of control. Two things that, frankly, an autonomous system should never have happen. So as we look forward to that, I think, you earn trust over time. I think that trust is earned by the introduction and the adoption of specific technologies to address these areas of safety that we can improve through the introduction of technology. To that end, I don't think there's a cliff function here where people are just like, hey, okay, great, pull that person out of the front of the airplane and let's go fly. I think what you'll see is a transition and an evolution of the role of the pilot away from the aviate and navigate, and with increased focus on communicate and manage, specifically in terms of contingency management, so that they're your Sherpa more than they are the driver, and then eventually I think that trust will be imbued into the system, where perhaps the Sherpa doesn't necessarily need to be on board at the same time. So thanks for the question. I hope that was useful.
Yeah, very much so. Thank you for the answer. Let's see, and I'm just going to flip over to see a comment here. There we go. And let's see, were there anybody else on the panel want to comment on that particular question? All right, we'll go on to the next one then. So the next question is for Jim. And this actually kind of feeds into some of your opening remarks about how Bell has been making helicopters for many decades. There's an established manufacturer of civilian helicopters that make fine aircraft. Do helicopters have a role to play in the advanced air mobility system? And following on to that, what are some of the lessons from helicopter development that can be applied to eVTOL and advanced aircraft mobility development?
Yeah, first I just wanted to actually follow up with John. I thought he nailed the conversation associated with pilots. What does everybody like to see in their pilot when you get on board an aircraft? A little gray hair, right? Nobody wants the young guy. So autonomy is that bridging ability, the reduction of the cognitive workload of your pilots. So we start out incrementally with the gray hair, then we go to the young guy, and then eventually maybe there's a flight steward on board, and then we finally get rid of it as we build the confidence. So yeah, I think it's spot on in the discussion. It's incremental. It won't be one day everybody, surrendering their lives to a computer. So to answer your question about helicopters and air mobility. So advanced air mobility is really just an evolution of the existing helicopter role. I mean, while eVTOL holds the promise of affordable air mobility, helicopters are truly the original VTOLs, providing a solid starting point for the discussions on things like airframe certification, safety, cabin comfort, pilot qualification. And they also provide a pretty good insight into existing business models, profitability. I mean, I'll give you an example today. You can catch an air taxi 5 minutes from Manhattan to JFK. It'll cost you $170, and so that's probably not viable for the most of us, but it would be a Bell product. So what I'm really getting at is, bottom line, existing helicopters not only have a role to play as a key enabler in establishing this new transportation network. So they're going to be, in some cases, they're going to be surrogates when we're testing autonomy, where you can have a man on board, but you're still getting all the benefits of the control in the loop. And then, you ask a tougher question in the end of your discussions in the helicopter developments. What can we use to inform the eVTOL and advanced air mobility? And I got to tell you, for the crowd, certification is hard and it's expensive. And so this is going to be our really great challenge. And in anything you hear me talk about today, it's going to be about how do we get that path to certification as quickly as possible and as repeatable as possible, so that we don't get locked in a trap where it takes a decade to certify a new technology.
Excellent, thank you. Does anybody else want to chime in on that? My next question for Greg actually follows up on that, but just want to give you guys an opportunity in case anybody would like to add on to that. Okay. Next question. So for Greg, this follows on what Jim was just saying about certification. So you've spent much of your career working in the areas of aircraft certification and standards development. Could you talk about any particular pitfalls that you think that the AAM eVTOL industry is particularly vulnerable to? And without giving away the farm, can you talk about how your company Joby is avoiding any of those pitfalls?
Yeah, absolutely. Thanks very much, Carl. So am I buffering? Okay, I think I'm okay. And so I wanted to certainly indicate that communication is the key. So I think that we've seen new entrants in the past. Like historically, pitfalls have been a new technology comes along with the assumption that it will fit into the rules, and then coordination with the FAA occurs after the designs are complete. And the FAA is in a tough spot because they've found some things they don't necessarily think are compliant. And the applicant is in a tough spot because they've got a pretty mature product that they don't want to make changes to because it will add to the timeline. And so there's a stalemate occurring. So what's been really important and what's been refreshing, the FAA has stood up an innovation cell where they've been engaging really early with applicants and having early conversations as these vehicles are in the maturation stages, when there is flexibility in the design and when there are chances to come up with better paths of compliance working together. The FAA has been doing that individually with applicants. They've been taking that knowledge to standards bodies and institutionalizing that information so that others can take advantage of it. And so that approach has been really successful. Certainly, I would indicate that Joby has been part of that approach. I think every company on the call, in fact, has been party to this kind of approach, this more collaborative approach on certification. And so it's a pretty healthy environment at the moment where FAA is willing to look at new means of compliance. They're using the flexibility in the regulations they have. It's interesting. EASA has published a whole new rule set, a set of special conditions called CS VTOL, with obviously the newest means of compliance out today, or a couple of days ago, the 25th. The FAA has taken their existing set of rules and has made small tweaks through special conditions and has built means of compliance using existing means of compliance and only generating new ones where necessary. And so that has resulted in a pretty efficient path. And I think it's a path that is good because it only modifies the system in the places it needs to, and it gets all the heritage and all the lessons learned out of the system where it can. And so I think we're very lucky to kind of have that environment going on right now.
Okay, great, thank you. Let's see, and then again, anybody want to chime in on top of that?
Yeah. Hey, Carl, David, I'll chime in on that. I think that one of the pitfalls that I've seen prior to this is that it's not the FAA's job to tell you how to design your aircraft to be compliant. I think a lot of newer companies come in and want the roadmap, and the FAA is never going to give you that. What their job is to do is to tell you, here are the regulations that we're going to certify the vehicle to, and here are the means of compliance. Now, you can always offer other means of compliance, but again, it's your job to provide that. And where other newer industries have I think failed sometimes or slowed things down is the amount of time they've argued with the FAA over these issues. And in the end, to be quite candid, the FAA wins. They're the regulator. And not that they're not willing to change their minds, but you've got to have a darn good engineering case to do it. So as much as we can look at things as they exist today and adapt them to our needs, I think that's what's going to generate the successes that we need now and into the very, very near future.
Great, thank you. All right, well, why don't I'll move on to my final kind of directed question here, and then after that, I'll probably go over to a couple of the Conference IO questions, because I've noticed a couple of good ones in there. So this question is for Tom. So Tom, WISC is moving forward with demonstration flights in New Zealand. I was wondering if you could talk about kind of what motivated the decision to do those trials in New Zealand, and following on to that, what are some of the kind of commonalities and differences that you're seeing amongst the various aviation authorities around the world when it comes to advanced air mobility or eVTOL certification?
Thanks for the question, Carl. The New Zealand government is very progressive in its environmental initiatives that include transportation. Therefore, WISC is a natural fit to bring zero-emission flight to the region. With regard to aviation authorities around the world, we're seeing a strong demand signal to get advanced aerial mobility and eVTOL in the air. And whether it be EASA's SC-VTOL, the FAA's use of Part 23 Amendment 64, the New Zealand CAA's various regulations, and most recently China's efforts, everyone in the regulatory space is seeing the potential these aircraft bring. So you're seeing a lot of creative thinking on how to do that within the various regulatory frameworks. Commonalities include how to contend with issues we've discussed here today, or we will, and such as innovative propulsion, batteries, etc. Differences include making old rules work on new aircraft, like what FAA is doing, or creating new rules for those new aircraft, like EASA is doing. In the end, we won't know which approach is better until we start seeing applicants getting airworthiness certificates for their eVTOL aircraft.
All right, excellent, thanks. And again, does anybody want to follow up with that question? All right, well, why don't, so I think what I'll do next here is I'm going to go over to a couple of the questions that are popping up on the social Q&A, just so we can make this a little bit more interactive with the audience. Now, this first question has to do with EASA's means of compliance that I believe this was as part of what was just published a couple of days ago. So this is all pretty fresh, and so if nobody has any answer to this at the moment, I think that's okay. But the question here is, what are the panelists' thoughts on EASA's means of compliance guidance for energy storage crash resistance for eVTOL aircraft? Is it good or is it bad? And I will admit that I haven't read this, so I actually don't know exactly what the question is referring to specifically. Hopefully somebody on the panel does, though. So,
Carl, I'm happy to touch on this.
Yep,
so Yep. The approach in general that EASA has taken is to pull from rotorcraft lessons learned and institutionalize those, and then kind of adapt that. The other thing that's interesting about the SC-VTOL is it incorporates operations and aircraft design together into one special condition. It kind of deals with operational issues as well. And so in the US system, we kind of kept those things separate as we traditionally do with aircraft. One of the areas that EASA touched on was battery safety, and they look at they try to make a parallel approach to helicopter fuel tank safety. So there's been a lot of emphasis on making sure that fuel tanks don't burst when they hit the ground, and so there's been a recent set of rules dealing with fuel tank safety. The EASA path has been to make sure that you restrain energy in that kind of event. And allow for safe evacuation, and they draw a parallel to the fuel tank safety rules. I think that they didn't actually define in specificity what that means. Can the battery burn? Can the battery flames come out? When we look at this issue as an industry at large, we've had good discussions across the industry. I think one of the key issues with liquid fuel is that when there's a crash with liquid fuel, it hits the ground, it pools around the aircraft, it creates a dangerous environment for the evacuation. Batteries, by their nature, don't have liquid fuel and don't pool in that way. But what they do is they're massive and large, and they will fall somewhere. So looking at those issues specifically, so issues of electrocution, issues of where is that piece of mass, and potential overtemperature issue going to end up. Those are the key issues, and the FAA has spent their time in those areas. I don't know if EASA has put anything more specific forward. They've essentially just referenced the helicopter fuel kind of rule. So I think there is some latitude with the EASA approach, but being based on the liquid rule seems to leave a bit open to discussion.
So if I can jump in a bit, I think EASA, both EASA and the FAA, in my opinion, have been doing a great job, like Greg said, talking to the industry and the applicants, and collaborating on putting together means of compliance and rules. I think maybe the question refers to there's some language around drop test requirements in the MOC's 50-foot drop test, and some specific numbers, 15 minutes of the battery being safe in terms of crashworthiness for liquids and gases and things like that, without commenting specifically on those details of like 50-foot versus something else, or the time duration. I think the approach of collaborating with industry, with the applicants, and kind of iterating on those rules and see what makes sense for those new airplanes, those new technologies, is good. Just finding something that enables those vehicles to be certified in a safe manner and in a practical way too, that takes into account the new technologies, the differences and the similarities. Like Greg said, a battery is not the same as a fuel tank.
Excellent. Thanks, guys. Let's see. Well, why don't we? I'll move on to the next question that's in the conference IO here. And so the question here is there a distinction between the type of aircraft that might be used for or by municipalities for various public activities versus commercial or passenger use? So I suspect that the question is referring to things like EMS and those sorts of use cases, as opposed to passenger transport. Or potentially also kind of municipal buses and that sort of thing, air buses, if you will. Anybody care to comment on that on the panel?
Well, I'll jump in and offer an opening salvo on that.
Sure.
And you meant airspace bus, I'm sure, but yeah.
That's exactly what I meant.
So I think, when it comes to aircraft design, it's certainly the end user is an important consideration, but it's really the end use that drives most of the variables that are inputs to the design process, right? So you have to consider that use case and specifically the mission of the air vehicle. The air ambulance case is a great one in that, it has the potential to provide a use case to our industry that allows us to garner that public trust and public acceptance because the benefit outweighs the nuisance, right? So that's a really interesting one. But from a design perspective, you're transporting a payload from A to B. Certainly the interior capabilities you might need to have in terms of, oxygen systems or electrical systems to support the extra monitoring equipment for a patient in need. That creates some interesting requirements for the payload compartment and maybe some of the power and distribution systems on board the airplane. But fundamentally, the mission is still the same. It's an A to B mission. So when you look at other municipal use, and airborne mass transit, that's just, okay, that's more payload, shorter range, obviously imparts different requirements on the terminus, your arrival and departure places. So I think, it's really the use case that drives more of the design inputs than it does the user. But as a start to the discussion.
Yeah, I would amplify. I think I agree with all your points. And, in the post-COVID world we live in, I think we're all looking at the importance of municipal uses and ways to help society in general. So I think that these aircraft can lend pretty well to a lot of new missions, and doing some analysis of what these vehicles can do in that regard is smart. I think there's some companies, if you were to talk to the folks at Beta and some others, they'll kind of talk specifically about some of these missions they're looking at, like human organ transplant, transportation, and some other things. And so I think all of that is exciting because the cost, the nature of the lift, the nature of the cost effectiveness introduces a whole lot of new opportunities for aviation. I think what we all get most excited about is the idea that aviation is just becoming a more common thing for us. So just as maybe our grandparents and parents endured the commercial airlines being much more expensive and difficult to access, and nowadays it is much more of a ubiquitous form of transportation. I think we're on the verge of that for personal aviation, where folks don't have to fly themselves. They can have access to this kind of transportation in the air in a much more effective and low burden way. And so when we start to think about that, there's all kinds of uses. And so that's exciting.
All right, great, thanks. And I'm sorry if anybody's wondering why I'm looking off to the side. It's because I have the all of the questions are on a separate computer here off here. So I promise I'm not totally distracted. No, I think this is a really good discussion around around how the use case drives the design and vice versa. So why don't we'll move on to the next question that I've got here, which was an interesting question. So what is the best way to connect suppliers to the appropriate contacts within a vehicle manufacturer? Would it be to assemble a database? It's a bit of a tough question. Curious if anybody on the panel has an answer they'd like to give for that one.
Well, I'm happy to start that one. I think, from the Boeing perspective, and I'm sure, other participants on the panel would probably agree with this, your supplier network, your supply chain is, built and matured and quality checked over a long period of time. So, at least from the Boeing perspective, we start with our known goods first, because we know that they have quality control plans in place. We know that they routinely audit. We know that the quality of the output product that goes into assembly line for us is at a certain standard such that we can stay efficient and keep a high level of quality on the end product. So I think That's not to say it's impossible to become a new supplier in aerospace. What I will say is that, do your homework and make sure that, you understand what a true quality program really is, and you're able and in a position to represent that quality program to an OEM, because at the end of the day, it's our label that goes on the metal sticker that goes inside the aircraft after it gets certified, and we're the ones that hold the liability on the safety of that aircraft. So we're gonna push that level of responsibility through the supply chain, and I'll apologize in advance for how hard it is to become a Boeing supplier. Once you do, you're there for a reason, and that is you've established that bar of quality, first-time quality and safety as a part of the way you operate your supplier things, your processes. So there are mechanisms. We have supplier management organizations in each one of our companies, I'm sure, that have that responsibility. They're open to talk. They're open to engage. Just know that that's kind of the bar going in.
Great. And so, one thing I'll just add briefly is that, as for this particular working group, and one of the things that I think that this group can do to be valuable is to help kind of make these sorts of connections. And so, moving forward, we'll be, trying to come up with ways for different folks who are involved and kind of watching this group to interact with each other. We don't have those stood up yet, but I think that's kind of part of the vision here. And so that will allow some of those connections to be made, and allow the suppliers who may be at that level of quality that John's talking about to be able to reach out and connect with people, because that's one of the things that we really want to do here is help the community to engage with one another. Let's see. Were there any other follow-up comments from anybody on that particular question?
Just maybe a note that this supply chain question is one of the critical points, I think, of making this a reality in the short term. Is a new supply chain that needs to emerge for some of those components that just don't exist right now, or just high performance, lightweight, low cost, but also high reliability systems like a powertrain, electric motors, inverters, fly-by-wire, all those things. And that's a lot of people in this field are looking for the suppliers, or I've found them already. As that's something that needs to happen in the next few years, demonstrate reliability by getting data. And that will probably be a mix of legacy suppliers coming up with new products or adapting their existing products, and new suppliers that kind of establish those quality insurance processes and move into the kind of aerospace reliability world.
Yeah, I want to add to that, Hervé, because one of the, that's one of my big concerns, the supply chain, and it's not around the reliability, it's actually around scale. So if you look at where we will be when we get to UML level of 5 or whatever it may be, then we'll be building products in theory on the same scale that we build some automobiles today. And how is automation, how is additive manufacturing, how is the reliability that is required for aviation products on an auto product scale, how is that going to work? And another big part of that is also, of course, the workforce itself. Will we have the workforce in place and available to be able to produce it? And that work, again, needs to start today, because if we want to be UML 1, 2, 3, early 2030s, are we ready to get there? And I question whether we are. So it is a big concern.
Yeah, I tell you what, Carl, I'll riff on what David just said and just share with the audience experience from one of our subsidiaries. In-situ is one of our subsidiaries that makes, long endurance, small unmanned aircraft. That Scan Eagle is, probably the most famous. And the engine in the Scan Eagle is a very special thing in that on the surface, the engine itself doesn't look that different than the engine you'd have in your lawnmower or your weed whacker. But the environment that we're putting that engine into and the mode of operation that we're subjecting that engine to drive a completely new set of requirements into the supply chain around all the way down to the sourcing of the raw materials for the metal. So I think, David, I completely agree, right? That scale, and especially if you lay on top of that the unique aviation requirements that are going to drive into some of these areas that today we're using kind of commercial off the shelf in this new area of AAM, and especially in the small UAS space, off the shelf electric motors. Well, when you really start using them, in a commercial context where you have to have a high uptime reliability, predictable curves for use and failure, that's going to drive new requirements into that supply chain, and that's a very interesting dynamic that I agree we need to start exploring these things now.
Hey, this is Jim. Another opportunity for us to all have at least one question we all have input to. So it's great that we got to this point in the event. Now we can all start to really get at those questions.
That's right.
Agree with what has been said on the discussions about the establishing of the first and second tier suppliers. Much of this doesn't exist. There's another added wrinkle that is to this that we haven't had before, and that is the focus on protecting the emerging domestic market. When you saw the Air Force roll out their Agility Prime, one of the big takeaways from that discussion was they didn't want to have what happened to the small UAS market happen to eVTOL. So you can expect the current administration and the Department of Defense, when they're interacting to work these actions, to talk much about who are your suppliers, and so therefore it's going to add an extra wrinkle that we haven't had to do in the past, where they're going to want to focus on where are your domestic suppliers as opposed to getting the best value internationally.
Yeah, actually, I think I'll take the opportunity there to actually add another question from the panel here in terms of that is related to what you were just saying, which is asking could panelists comment on the EASA announcement earlier this week on the eVTOL standards framework and what that actually means for American leadership in this technology. This working group is it's being led by NASA. We're obviously an American organization, and looking at the mailing list for this group, but we are mostly American based, but certainly have folks overseas as well. But I'd be interested to hear what the panel think of that question, and what it means for American leadership in terms of this technology. Having that EASA announcement.
So, Carl, I'll quickly jump on some thoughts. I think FAA has done a really good job of showing global leadership within their specific efforts, but they haven't produced any high-level rule change or policy change. And I think that's part of an intentional approach. So FAA has been discussing this for a couple of years, that they want to kind of put their money where their mouth is. They want to actually get results and get aircraft in the skies and flying safely before they institutionalize a new set of rules. And so that is the reason for the lack of new products out of FAA. It's actually happening on a project-by-project basis until they can standardize. I think in general, that's a good approach. The EASA approach is something different. It has been to kind of collaborate with the industry on developing a new set of standards and a new set of processes. And they've done that in kind of a relatively quick way. So it's been a few years that they've developed that material, and the new guidance material is out now. I tend to think that the FAA's approach of working project by project will end up being more quick. It'll be a more efficient process to get those products safely into experience. But the world will continue to watch and see how it goes.
Mm-hmm.
Yeah, I'll second that. I think the FAA has been very, very active and took on the challenge of adapting to those new technologies. They have given no specific rules quite yet, but pretty clear signals to the industry that some concepts can go the normal Part 23 route. Some indications of what maybe concepts that look more like helicopter can expect. And then really collaborate with multiple applicants on their specific concepts to find a way to certify. So both EASA and FAA are very active and allowing industry to make progress.
Great, thank you. Tom, were you going to try and say something?
Yeah, if I could just add
go for it.
On that. The industry, of course, would love to see one set of rules globally. And so that, I think, is a nice thing to strive for, but maybe it'll never happen, mainly because every system is a little bit different, so you can't always completely harmonize. So on the one hand, it's really good to see both the level of activity of FAA and EASA, and that they're engaging with the industry as much as they are. And I think most people would say that between the two, that's kind of the gold standard for which the rest of the world is likely to follow. And therefore, it's kind of nice to know that you only have two principal entities that you want to work with. And there has been a lot of effort with the industry to work both with FAA and EASA to try to work through this, but it truly is something that can only be figured out between the two. And because this is also new, it's likely to take a while before we could expect to see harmonization to the point where we could feel confident that if we were to get certified in one system, we could get through the other relatively quickly. So those, I mean, it's a global marketplace, so most are looking toward how to most efficiently do that, and some are choosing one or the other. Some are going joint, and as has been said, we'll have to see how that works out for those who are the first ones through the gate and learn from that.
Great, thank you. All right, well, I want to pivot over it a little bit here, if we could. We've been kind of beating on some of the certification issues here. Let's talk about technology a little bit, and I'm gonna go back to one of my kind of pre-canned questions here, which is, you know, and this is a bit of a selfish question as well. You know, I'd like to hear from the panel. You know, what are some of the technology areas that you think that companies can get the most value from collaborating with the government? You know, in particular NASA and the FAA.
I'll offer one that is around communications and spectrum. It oft goes overlooked when you start to think about removing, you know, maybe it's not full command and control, but just in terms of reliable connection for telemetry of vehicles that are going to be optionally piloted or fully autonomous, protected spectrum becomes pretty important. And when you look at the distribution of spectrum today, there's not a whole lot of space. So I think, you know, this is where industry and government absolutely need to collaborate and find ways to provide the entire community access to protected and reliable spectrum. I think other areas that are common to kind of the safety of operations of flight are important areas for collaboration. You know, and we're guilty of this just as much as anybody. You know, when you think about unpiloting a system, you say, oh, we'll put a GCS on the ground and make it look like a cockpit. And now everybody starts building their own GCSs. But honestly, like, is it going to do the community any good if we all have a bunch of different bespoke GCSs and different interfaces? Probably not, right? We have the standard 6-pack in general aviation aircraft today, largely because that standard improves the level of safety in aviation. So, aspects like that, command and control, protocols, cyber, all of these areas, I think, are ripe for great collaboration between industry and government that give us the foundational structure that we can all benefit from, and the flying public benefits from through its safety.
Great, excellent. Other thoughts from the panel on the kind of prime areas for collaboration between industry and government here on technology?
Maybe thinking through some of the areas where there is already a lot of discussion going on, but that are key technologies. I think noise prediction, we already talked about noise, but especially on the ability to predict broadband noise accurately. That's, I think, where someone like NASA has expertise that can be applied to that problem would benefit everyone. A lot of activities or interest, at least, on new methods or processes for fast and efficient development of trusted software, complex software. Very much key for going into those kind of more complex functions we all want to use, and going towards autonomy or SVO, simplified vehicle operation. Things like building the safety case for some of those technologies, like sense and avoid or allowable traffic density, network-based reserves. I think NASA and FAA have expertise and experience like building those simulations, those safety case. How much range do you need for those technology? How much delay, timings, this kind of things. It's been discussed also in the past, but I think that makes a lot of sense. Data sets for state estimation or perception technologies when you look at automation, or even modeling frameworks that people can use that let them more easily model radar, LiDAR, cameras, whatever, and kind of develop their technology based on that building blocks. And I think what was already mentioned around those technology, especially when you look at SVO, there's a pilot or an operator that's still present to some extent, at least in the medium term. And so all the aspects of HMI or human machine teaming, where FAA and NASA have a very, very deep expertise. I think those are all areas that are very interesting.
Excellent, thanks. Any other thoughts, folks on the panel?
Yeah, it's Jim. So having worked with NASA in the past and currently, the things that we know that you bring to the table are science and credibility. So if we did something by ourselves, it would not stand the same kind of test as if it was a joint effort with NASA. So we see that the credibility of NASA as we work towards establishing a path towards certification is going to be very important. That things that we can prove out the science so that when we're taking it to the FAA, we have it documented and repeatable. Those will really go a long way towards advancing certification. And then from a technology perspective, NASA has some really good, interesting work with battery cell chemistry and packaging, high voltage power switching. These would be helpful to explore.
Great, thank you. Okay, let's see. I'll go back over to the conference IO. This is another technology question. What do you think are the human factors challenges for designing displays and controls for these highly automated revolutionary air vehicles? So this gets back into our discussion of the human pilot versus the automated pilot and making that all work smoothly. Anybody want to jump on that one?
I would reference the SVO white paper that was written that talks about that. I'm not sure I could quote it chapter and verse, but there was a lot of effort put into that to address that particular question as to how to approach increasing autonomy in the cockpit, and what some of the issues will be that'll have to be dealt with, because that HMI is an interesting area to explore when you start talking about what or who is responsible for an action, and same with the decision making. And at what point do you cross that line between the human being the ultimate backstop and the machine? So that's something that I'm sure there'll be lots of discussion about for a long time to come.
I'll quickly kind of leverage on Tom's comments. I think absolutely the SVO material is really helpful, Tom, as you said. And in addition, I know the FAA has spent a lot of time working on mission task elements and pulling out of, and NASA, there's a good working effort there, pulling lessons learned out of the military, the years of flying STOL aircraft like the Bob Harrier, the Harrier, the F-35B. There's a lot of lessons learned about how to create a set of inceptors that allow the pilot to know what's happening, intuitively get the aircraft to do what it wants. So I think that's some good work that's going on. I think in addition, there is some ability. Ideally, piloted aircraft would be straightforward and simple. The idea of the six-pack, the modern six-pack, is a good concept. I think in practice, we're asking pilots to get a sense of how fast the aircraft is moving, and so some of the skills that are really important are to decelerate this aircraft efficiently, transition back onto the wing if you have a wing towards the end of the flight, so that you're keeping the most energy efficient phase of flight happening. So you're on the wing as long as possible, and kind of doing a nice continuous deceleration, ending up exactly where you want to be, and then setting down. So tools that add to that technique those are probably helpful tools. In general, there's been a lot of work that can be leveraged in this space. So if you look at the ways that we interface with radios and navigation, that's all pretty mature, but certainly the vertical aspects and the energy planning aspects are important as well. And certainly there's good work happening within NASA, within the FAA, that we'll all leverage.
Maybe for a somewhat like more medium long term, some like high level principles. I think there is a good level of consensus on the industry for some like big picture concepts and traps to avoid. A lot of people agree they want to kind of get away from the very high training supervisor pilot concept and have automation that's robust and fail functional. Not keep adding as you add automation, add kind of supervision task and training for the pilot to deal with the failure cases. And that has impact on things like trying to avoid reversionary modes, for example, or really deal with automation in a way that is as health monitoring and self-checking and fail functional. So those types of approaches that are highlighted in the SVO concepts, I think make a lot of sense, and are fairly different from kind of historical automation approach on like airliners today.
All right, great, thank you. Let's see, I want to move over to, I've got one more kind of technology question that I want to get into, and then we're reaching the end of our time here, and so then I want to get into a couple of wrap-up questions. But so one technology question that I'd like to get the panel's input on is, we mentioned batteries and electric propulsion, multiple times here. Most of the proposed eVTOL or urban air mobility vehicles are depending on battery-fueled electric propulsion, which requires energy capacities and component reliabilities that are they're beyond, pretty well beyond what is currently available. And you can feel free to disagree with me on this point, but that's kind of my observation. I'd like to get your take on, how does the industry adapt if all of the other pieces have fallen into place, the CNSI pieces, the airspace pieces, passenger acceptance, all those things have fallen into place, but a single this big chunk of it, the electric propulsion component, isn't there. How do you think the industry adapts in that case? How does it move forward?
I guess I can take a stab at it. I think you need to separate reliability and performance, which are really different in that context. And on the performance side, it's really kind of concept, depend on your concept, your mission. And for Uber, at least, that's really at the core of the application we're looking at, short range urban application, where we think current battery technology works and provides you with enough productivity to have a product that makes sense and provides value to the customer. If you are talking cross-country or very long range, then looking at hybrid or potentially fuel cell makes sense. So kind of use dependent. On the reliability point of view, it's really a completely different question, I think. Do fuel cell have higher reliability than pure electric? That's unclear to me, at least. If you look at a hybrid system, you still have your electric powertrain. Do you really gain in reliability? It's also not a slam dunk. So you already need, going back to the supply chain question, you already need to have high reliability for your components, and you pay a price for it in weight, in development cost, in cost of components. And reliability is like a first-class citizen in the multidisciplinary problem of airplane design, essentially. And then you have the architecture approach of having redundancy or other ways you architect your system to deal with that. Potentially operational mitigations like inspection or service interval. Those things have an impact on DOCs, the operating costs, but as that's traditional approaches. Also very exciting opportunities that I think a lot of people in the industry are looking at for HUMS or health monitoring, looking at predicting failures, collecting data from those very much digital airplanes.
Excellent, thanks. Let's see, does anybody else want to comment on that one?
So, Carl, I'll just come back to the original. It's about the use case, right? And there are certainly use cases where a battery-driven electric propulsion is going to be suitable. Actually, might be optimum. There will be others where reciprocating engine probably is still going to be the best option, and there'll be others where a turboshaft engine is still going to be the best option. So I don't think it's a one size fits all. We've done some, and we have some ongoing programs around the exploration of fuel cell hybrids, which offer some interesting promise. But each one of these approaches has their own advantages and disadvantages. For the fuel cell case, it's about the production and storage of the fuel itself, so that you can have a network and an infrastructure ready for fuel cell refueling. But the performance, we've been able to fly a fuel cell driven ScanEagle reliably. So I think there's promise there. But again, matching the energy source and the propulsion mechanism to the use case is really where the rubber meets the road.
Excellent.
Yeah, I wanted to tie in that conversation with the one we were just having about the pilot's display. As we look into this, we talk about all power sources have trade-offs, both from safety perspective and cost. But a lot of what we're talking about now is about making the business case for a new model, and it's about driving down the cost. So if you were getting to the lowest potential operating cost per mile, you're looking at a battery-operated eVTOL that's fully autonomous, because While having a gray-haired pilot on board the aircraft is comforting, he is taking, or she is taking, one of the seats that could be paying. And therefore, as long as you have somebody on board the aircraft who is not a passenger, it's an inefficient model. And so it's the same thing with the batteries, that we know that if we can get it to high-capacity batteries that can give us the greater range, we'll drive it down to the least operating cost. And then from an infrastructure perspective, we won't have to worry about refueling aircraft on the top of buildings or other places with conventional fuel. We'll be able to go back to the concept of an electric grid and then use whatever source works, whether it's renewable or off the main power grid. And so if I were going to drive this all back to a point, and that is that the advancement in battery technology will benefit us all. And so it should be seen as a team sport and a priority.
No, absolutely. I couldn't agree more on the battery technology being a team sport, because if the batteries don't get there, it kind of blows a pretty big hole in what we're all trying to do here. And so, that and certainly advancing all of the other technologies is something that we can all benefit from. Okay, let me ask, I'll just do one more question here, and I think this is a pretty quick one, just from the conference I/O. To what extent is urban air mobility expected to address IFR operations? VFR only operations may limit UAM acceptance. Cars wouldn't be very popular, for example, if they weren't usable in rain or fog or snow or any of the other terrible weather that we tend to see. So any opinions on that from the panel?
Yeah, I think, Carl, as we look forward to this future of AAM, we are introducing a transportation modality that is much more sensitive to weather conditions than the alternatives that exist, right? So whether it's rail, whether it's road, whether it's biking or walking, there's a level of reliability in each one of those that a daily commuter or a person who needs to get from A to B urgently, or a package needs to get from A to B reliably rely on. And weather's effect on aviation is well known. I think it's absolutely remarkable that in the airline space we have the kind of on-time performance that we have today, considering the wide weather conditions that we encounter, and that's a tribute to the system and decades of fine-tuning and iteration. So I think when we look at AAM, absolutely, I don't think that the business case really closes very well if the industry and the community says, oh, well, it's got to be nice weather and less than 20 miles wind, mile per hour winds no, you got to have some utility built into this. Because then, if you do have a high degree of sensitivity to, launching and recovering the aircraft, well, now you have to consider what that consumer impact is. And then how do you manage that repercussion through your consumer experience value chain? If somebody is counting on that, 7-minute flight to JFK, and all of a sudden some weather moves in, well, now I might not be able to make my flight. And whoever the service provider is, now they have an extra burden to try to manage that ahead of time for their customer to have a great experience. So I absolutely think all weather is something that has to be in the design considerations for AAM aircraft if we're going to see a business case close.
I agree that consistency of the product is really important, quality and consistency. The way we are looking at VFR and IFR currently is that VFR is a great way to start. Have a pilot do a separation and use existing VFR rules for airspace and for certification. So it's a great way to get going, have a first product. But definitely we want to move towards, so a bit unclear if it's IFR, but at least IMC, flying into a limited visibility conditions, having lightning protection, having some capability to deal with wind. And here there may be that medium, longer term work that needs to be done on the airspace integration front, because one aspect of IFR is the separation minimums that are associated with it. And here, things like UTM will help kind of deal with that aspect.
Hervé, I'm really glad you made the distinction between IMC and IFR. I think that's very important, right? And this is one area where a trend towards autonomy, I think, actually does improve safety. And that is, you know, the instrument meteorological conditions for a human pilot are the highest stress environment for operating an aircraft. And an autonomous system largely doesn't care, provided the performance envelope can deal with those weather conditions. So I think, you know, perhaps the question is really about whether we need to be able to fly an IMC. And the answer is yes.
I completely agree. All right. Well, we have about 10 minutes left, and so I want to try and bring things into a close here. And in doing that, I think you know, I want to bring it back to this working group and how we kind of go forward. And so I guess I'd like to get an opinion from each of you on the panel. You know, what do you think is the main potential benefit of this working group in particular, of this aircraft working group, and where can it add value to the kind of whole ecosystem? And why don't we go? We'll go in the same order that I asked the original questions. So we'll start with Hervé.
I mean, I think in general, dialogue is very important, and there are lots of stakeholders. There are other avenues for looking at community engagement, but that's kind of the concept of regulators, industry, standards, organization, like all those communities need to talk to each other to get to the finish line. So that's one venue for making that happen. I think collecting ideas and consensus essentially on what efforts are highest priorities, a kind of discussion we had on core technologies where NASA or FAA can contribute. If consensus emerges on these kind of things, maybe that helps those organizations make decisions or allocate resources. And on the other side, also sometimes identifying different products, different markets or approaches can be healthy as well. Diversity is healthy and valuable, and maybe there is not just one product, one road for everyone to move forward there. And the renaming to AAM shows that a little bit. So those are aspects, I think, where the group can have an impact.
Okay, great, thank you. David, same question.
Yeah, I think very simply, I think that it's to help us understand where we all agree, right? Because if we can find where we agree and we can build consensus around those areas, those give us the obvious near-term points that we can go work and accomplish things in. There are going to be thorny issues that we, in this group, we're going to have to unearth, but we got to maybe put those to the side. Otherwise, we'll spend time arguing as to whether, as opposed to going and doing. And so I think at this in these still relatively early stages, as much as we can go do, let's go do.
All right, excellent. Thank you. And John, same question. Where can the aircraft working group add value?
I'm smiling because David and I are using the same term. I was about to say go do. So awesome, David. You know, these working groups or any other kind of consortia of industry and government are unique positioned to create a bit of a steering committee. And again, find that common denominator where we can go focus energies collaboratively and collectively to get to a foundational baseline. I think I'd also add, you know, one of the unique things that I think NASA presents to the community is the ability to go do in certain circumstances where an individual company and industry might be challenged, because at the end of the day, we've got to make an internal business case to allocate the resources to go do something like air-to-air DAA testing, just to make something up, right? That is the combination of the working groups to identify that as an area of ambiguity that needs clarification, and then NASA's ability to go out there and go do and explore those things to create some real data that then the regulator can use as input, or the standards bodies can use as input to create the structure that, you know, us in industry so desperately crave. I think that's where the unique position and the value proposition really sits.
Right. Excellent. Thank you. Jim, over to you.
You know, I'm trying very hard not to be derivative, but at some point in time, we're all saying some of the same words. So I would say these kind of working groups elevate the conversation, they create shared expectations, and then most importantly, it provides a venue for collaboration. I think that was said by others, is this is an opportunity for us to get together and not be internal to our own companies and worried about our own IRAD. We're able to discuss things that have joint benefit.
All right, excellent. Thank you, Jim. And Greg.
Hey, so I think that NASA has a tremendous ability to communicate much more broadly than any of us individually, even better than some of the associations. NASA has a really strong brand. It's a trusted and technically savvy organization. And so I think that the work we bring to NASA and the ways that we might communicate the safety pieces, the benefits that these aircraft can bring, and some of the technical credibility that these aircraft have through NASA is a strong possibility. And so I think, as you know, we all have to engage with a whole lot of municipalities. This is, well at its root, this is pretty straightforward. An evolution of what we've been doing. It's an aircraft. These are aircraft that can fly in the airspace. They're not too radical, but at scale. And as this starts to take on congestion levels that are new, and this ability to leave from maybe a vertiport in your own neighborhood starts to be conceptual, I think that is when NASA being attached is really important.
All right, excellent, thanks. And Tom, how do you see this aircraft working group adding value to the industry?
So following the Go theme, it seems like this is a great opportunity to either define or refine what the major areas are that are most critical to move forward the fastest. And then I would hope that there'd be a connection with a national campaign, because I consider that kind of a Go avenue, in that the purpose of that, at least to some degree, is to go out and test. And that if we could help in this working group to define those areas that are most, would bring the most value in the shortest amount of time, that might be a good connect.
All right, excellent, thank you. All right, well, in the very short time that we have left, I'd like to give everybody an opportunity for just some very quick closing remarks, and I'll probably go in the same order, but I'll start kind of in the middle, so Tom doesn't have to go last again. So we'll just start with Jim. Any quick closing remarks for the community here?
No, just thanks for the opportunity. It was great to have this chance to talk with peers, and we look forward to the future collaborative events.
All right, excellent, thanks. Greg?
I have nothing special to add. Thank you very much. I look forward to catching up with everybody, and hopefully in person sometime soon.
Yeah, that'll be nice. Tom?
Not much to add there. I appreciate the opportunity to share with everybody and look forward to doing more.
Okay, excellent. Hervé?
I'm just thanking the audience and people on the NASA side who have set this up, and I think it's been a pretty successful given the constraints that we're all operating in. Thank you.
All right. Thank you. David?
Like everybody else, thanks. And more importantly, I hope that everybody who was listening found it as interesting as I found it, talking to everybody on the panel.
Excellent, thanks. And John?
Yep, indeed. Thanks very much, and kudos to the folks on the NASA side who who put this together. I know this is not easy doing this in this environment, and you iterate on different tools and technologies to try to make it happen. And, incremental step forward. Nice job. Appreciate the invite. Thank you.
All right. Thank you. And just for me, I want to say, thank you to all 6 of you on the panel: Hervé, David, John, Jim, Greg, and Tom. It's been excellent talking with you guys for the last couple of hours. I think this has been a great discussion. Certainly have, like I said in my opening remarks, certainly not going to touch on everything in a 2-hour session, or even in a week-long session. We wouldn't be able to hit on everything. But this was just kind of an opening session to get everybody kind of thinking about these types of aircraft problems and issues that we still need to attack moving forward. So I will let me just real quickly, I'll just put the kind of upcoming events back up here on the page, just so that everybody can see them, and we'll kind of leave that up there to close out. So like I said, thank you to everybody for attending. I hope this was very useful. I know we had somewhere in the neighborhood of 200 people on the YouTube stream, and there were somewhere around 100 people on the online question and answer. So overall, I think this has been a very successful event. I appreciate everybody attending, and have a wonderful rest of your afternoon. Thank you very much.